Chapter 8. In this chapter, we're going to look at special water-based fire protection systems. State 3 reasons why, under certain circumstances, the installation of specialized types of water-based fire protection systems is a better choice than standard automatic fire sprinkler systems, and discuss the characteristics and applications for fixed foam systems. Discuss the characteristics and application for foam water sprinkler and foam water spray systems. Discuss the characteristics and applications for water spray fixed systems. Discuss the characteristics and applications for water mist systems. Discuss the inspection and test requirements for acceptance of specialized water-based fire protection systems. Recognize the possible impairments to specialized water-based fire protection systems. When a standard automatic fire sprinkler system is not appropriate for the applications and conditions of a particular building, there must be an alternate suppression system, either standalone or supplementary to a sprinkler system. So let's look at alternative suppression systems. They can be specialized water-based fire sprinkler systems, such as low, medium, and high expansion foam systems. They can also be compressed air foam systems, foam water sprinkler, and foam water spray systems. Also, it could be water spray fixed systems or water mist systems. Specialized types of water-based systems are typically installed to protect special hazards, where standard automatic fire sprinkler systems are not appropriate, or where there is a need for supplementary suppression agents, and where the methods of application require specialized equipment and components. The differences between the four most prominent types of specialized systems and the automatic fire sprinkler system is the specialized spray nozzle instead of fire sprinkler heads. They also have integration of a foam agent with water in certain types of systems. They have specialized components, and they have design and application methods that are different from traditional systems. Both model building codes permit the use of alternative suppression systems. There is no code language specifying a certain type of system for the hazards. The use of a particular type of system is determined by its ability to protect the hazard. The design professional must determine the type of system best suited to protect the hazard and utilize the appropriate standard to implement the design and installation. So let's look at our first type of system here, a fixed foam system. A fixed automatic foam system protects flammable and combustible liquid hazards where two-dimensional surfaces fires are possible. The goal of designing and installing these systems is to ensure the system will accomplish one or more of the protective objectives, either extinguishing, preventing, controlling, or providing exposure protection for the following: flammable and combustible liquid processing, distribution, and storage facilities, large quantities or ordinary combustible material, or petroleum refinery storage and dispensing facilities, like tank farms, chemical plants, aircraft hangars, power plants, and rolled paper storage facilities. So anywhere that these products or things are going on, you're going to find a fixed foam system. When properly applied and proportioned, foam from these systems does the following. It's going to smother the fuel to isolate the ignitable vapors from the air. It's going to isolate or separate the fuel from the fire, and cools the fuel in surrounding areas to prevent further ignition. One manufactured foam product and equipment cannot combine with another unless listed or approved for that purpose. The ingredients must be mixed in the correct proportions in order to do the job effectively. Foam products are an effective agent to meet the production objectives of flammable and combustible liquid hazards. They are less dense than the fuel or water and will freely flow on top of the liquid surface. In order to produce a usable foam, a foam concentrate must first mix with water to produce a foam solution, and those percentages can be anywhere between 1 and 6%. Each percentage represents the amounts of concentrates that mixes with water to create the foam solution. NFP 11, standard for low, medium, and high expansion foam, recognizes a number of different types of foams in terms of the concentration. And they include such things as AFFF, which is aqueous film forming foam, AFFF, which is alcohol resistant aqueous film forming foam, film forming fluoroprotein foam, protein foam, fluoroprotein, medium expansion foam, and high expansion foam. So again, depending on the hazards and the cost will dictate what foam you're going to use. Once the foam concentrate and water mixes to the foam solution, the solution must mix with air to form the bubbles. The process occurs by a mechanical means. The foam products fall into three general categories, and that's low expansion, medium expansion, and high expansions. And that basically refers to the amount of bubbles you're going to get. Low expansion foams are used to protect outdoor storage tanks, interior flammable liquids hazards, loading racks, dike areas, non-dike spill areas, etc. They increase from a 2-to-1 to a 20-to-1 ratio. Medium expansion foams go from 20-to-1 to 200-to-1. And then the high expansion is 201 to 1001. And you would see high expansion foams and such things as airplane hangars and things of that nature. Fixed foam system components. Let's look at that right quick. Many components are the same as those used with other fire sprinkler systems. Additional components are necessary, of course, to generate the foam for the fixed foam systems. The proportion mixes the foam concentrate with water and sends it through piping to the foam generating discharge devices for application on the fire. And it's proportioned in three basic ways. It can either be used a Venturi proportioner, a pressure proportioner, or a balanced pressure proportioner, and that's just a way to add air to the solution to get the bubbles. You have a foam concentration tank. To avoid corrosion, it must be made of materials that are compatible with the foam concentrate or have a bladder that is compatible. The tank size depends on the amount of concentrate necessary to protect the hazards for the minimum required duration. Then you have the foam generating distribution equipment. Foam can be distributed subsurface, on the surface, into the side of a tank, overhead, or in a confined area. Subsurface injections occur inside a cone roof fuel storage tanks. Application requirements determine the types of equipment used to protect a hazard. Equipment includes some of the following: an oscillating motor nozzle, a foam making chamber, sprinklers, nozzles, and foam generators. Pumps. Installation to move the foam concentrate or additives out of the tank, so pumps are necessary. It should be a positive displacement pump because it is better than a centrifugal pump when pumping foam solution. You can also have a compressed air foam system, which it combines air or nitrogen, the water, and the foam concentrate in the correct proportions, using a mixing chamber to combine the solution that feeds the piping and flows to a specialized nozzle that delivers the foam. Foam used by these systems are Class A or Class B low expansion foams that protect flammable liquids, liquid spill fires, and three-dimensional fires. The design and installation standard can be found in NFP 11. which covers the design, installation, inspection, testing, and maintenance of fixed, semi-fixed, and portable foam extinguisher systems. Except it doesn't deal with deluge foam, water sprinkler systems, combined agents, mobile foam apparatus, Class A foam systems, or obsolete chemical foam systems. You would have to look at NFPA 16, NFPA 1901, and NFPA 1150 to cover those exceptions. Foam water sprinkler and foam water spray systems. These systems use foam and water as companion suppression agents, with the foam water solution used as the primary agent and the water used as a secondary agent. When the foam supply is depleted, the water supply continues until it is shut off. These protect basically your Class B flammable and combustible liquid hazards and certain Class A hazards as well. The primary design goal is to extinguish the fire, but they are also appropriate for prevention, control, and exposure protections. Foam water sprinkler and foam water spray system components. The components and operational concerns are the same as those for the fire sprinkler system. The installation is also similar, with the exception that a foam water system might be a pre-primed system. The piping contains a foam water solution instead of water. The equipment-related differences include the incorporation of proportioning equipment to make, obviously, the foam with foam concentrate. In some instances, the use of specialized foam water sprinkler heads or spray nozzles can be present. In order to look at the design installation standards, you must reference NFPA 16, which covers all our pertinent information from inspections, testing, and maintenance. And there can be some additional requirements that are covered in NFPA 30 and NFPA 409. Water spray fixed systems. These are fixed piping networks with specialized spraying nozzles. They are designed to protect a specific piece of equipment or the structural member surrounding or supporting the equipment. They may also be designed to function in conjunction with other fire protection systems as part of an overall fire protection installation plan. They are designed for the purpose of fire control, prevention, extinguishment, or exposure protection. The water spray fixed system components. They require at least one adequate automatic water supply that is connected to the deluge, pre-action, high-speed, and possible an alarm check valve. Your activation can occur by heat, flame, or gas detection. It may also have a pilot sprinkler head or nozzles. Automatic nozzles use the same basic technology as automatic sprinkler heads. Open nozzles have no heat-sensitive elements. They are available in high and low velocity. Plugs or blow-off caps may be used to keep water ready within the piping at all times. There are various types of steel and copper tubes that have been approved for use with these systems, such as galvanized and stainless steel. Acceptable fitting materials, depending on the installation, include cast iron, malleable iron, copper, steel, stainless steel, and ductile iron. Strainers should be installed in the supply lines or in some instances in each nozzle to help keep out contaminants and keep the system from getting clogged. Your ultra high-speed water spray systems. This is a very specialized system that must operate and apply water to the hazard within 100 milliseconds of flame detection. These systems require water to be in the pipes at all times. Pressurized water is released in the pipes upon activation of the system. According to NFPA 15, these must be able to provide 25 gallons per minute at each nozzle. They are used to prevent deflagration from becoming detonation. and appropriate for this situation where there is a possibility of explosion, such as a facility that manufactures and processes such things as solid propellant, rocket fuel, or ammunition. It protects an area or a specific hazard or both. Installation is limited to open, unconfined areas. And the design and installation standard, like everything else, it can be found in NFPA 15. Finally, let's look at the water mist systems. A water mist system is a fixed system that discharges a very fine spray of mist or water droplets out a specialized sprinkler head and spray nozzles. 99% of the droplets must be 1,000 microns or less in size. The droplets extinguish by cooling and displacing oxygen or blocking the radiant heat. The extremely small droplets provide a greater surface area for faster absorption. These systems protect land facilities and equipment, including such things as computer rooms, telecommunication equipment, underground mass transit systems, industrial machinery, electrical switch gauge rooms, transformer areas, aircraft hangars, aircraft cargo spaces, museums and historical buildings, hotels, commercial buildings, etc. They also protect offshore facilities such as yachts, cargo, naval yard vessels, offshore platforms, power rooms, turbine rooms, generators, and things of that nature. Anywhere where you don't want to use large quantities of water but still want a water-based extinguishing agent. The reason it's so much more effective is because the surface area is increased due to the small droplet sizes. Now, these systems can be classified in three following ways. It can be a total flooding type, which the entire compartment floods with water mist. It can be a local application, where water mist is applied in a specific hazard or object, or zone application. Basically, detection goes off, and then there's an equipment and control valve that determines which nozzles will flow. Now, these three categories can be broken down again, and it can be in low, intermediate, or high pressure systems. The systems can also be classified as either single or twin fluid systems. A single fluid system, there's only one pipe to supply water to the nozzle, and the twin has two pipe supplies with one water and one with gas. The advantage of these systems is it discharges less water than your conventional systems, and it is supplied by a clean, potable source. Normally easy to install because many are self-contained and do not need to rely on a water main. The disadvantage of these systems is it's a finite amount of water. There is a need for reserve tanks. There is need for testing and approval of each specific application. The design and installation cost is higher than your standard systems, and the nozzles can easily clog from particulate matter. Your water mist system components. The components are the same as standard systems, but are subject to very high pressures and require ratings far more than your traditional systems. Corrosion-resistant strainers must be installed beyond the incoming water supply or at the nozzle. And those strainers are there because you're trying to get very small fine particles, so the orifices in the nozzles are also small and they can easily become clogged. Heads and nozzles may be one of the following. They can either be automatic, non-automatic, or a hybrid type. Of course, the automatic, the head and nozzles have built-in flame detection and can activate devices that operate independently of other heads and nozzles. Your non-automatics, these are open, water flow occurs when the system valve releases upon activation of detection devices. And then finally, your hybrid types, they are able to activate by automatic or non-automatic processes. Once the system is activated, there are a number of different ways the water is delivered. and it can be done in pressurized gas, air housed in containers, or diesel or electric pumps can get the fluid there. The design and installation standard for this particular system is covered in NFPA 750. Inspecting, testing, and maintenance requirements. With few exceptions, specialized water-based fire protection systems go through the similar processes as those used for the approval, periodic, and maintenance of standard fire sprinkler systems. Failure to perform the various inspections and test results in an unknown operational disposition of the systems that could lead to system malfunctions. All systems are subject to the same acceptance, inspection, and testing, such as the hydrostatic, the air, the visual, the flush, operational, discharge, and functional testing. These tests are generally considered with standard fire sprinkler system requirements. Periodic inspection, testing, and maintenance. These systems experience the same types of impairments as the primary water-based systems. Impairments may result from one of the following: component failures, environmental conditions, damage, carelessness, and lack of proper inspection, testing, or maintenance. Typical impairments could include closed valves, painted, corroded, damaged, or obstructed sprinkler heads and nozzles, leaks, broken fittings, and broken piping due to freezing or impact damage. At minimum, testing and maintenance should be performed in accordance with the established intervals listed in NFPA 25 or described within the various NFPA standards for that particular system. Depending on the system type, NFPA 25, 11, or 750 establish inspecting and your testing intervals based on environmental and operational conditions. The testing and inspection range from daily to every 5 years. Foam and water mist systems require additional periodic flushing to ensure the removal of obstructions in the piping. If impairments occur, a plan should be in place to work around such impairments, such as implementing a fire watch, documenting and tagging the system out of service, and contacting all affected parties, and start the impairment investigation to expedite repairs. So in summary, specialized water-based fire protection systems include your low, medium, and high expansion foam systems, water spray fix systems, and foam water sprinkler systems, foam water spray systems, and water mist systems. Specialized water-based fire protection systems provide protection to hazards where automatic fire sprinkler systems would not be appropriate for the condition and application. Where there is a need for a supplemental suppression agent or different suppression agent, or where the method of application requires specialized equipment and components. In many ways, specialized water-based fire protection systems are similar to the 4 most prominent types of automatic fire sprinkler systems. However, the noted differences include the use of specialized spray nozzles and discharge devices instead of fire sprinkler heads, the integration of foam agents with water to protect certain hazards, the use of specialized components for the application, and the design and application method. Foam systems use different types of foam to protect hazards where two-dimensional fires are possible. These systems also protect facilities that store large quantities of ordinary combustible materials, including petroleum refining, storage, and dispensing facility, tank, farm, chemical plants, aircraft hangars, power plants, and rolled paper storage type facilities. Water spray fix systems protect equipment such as your electrical transformers, oil switches, motors, cable trays, paper, wood, textiles, flammable liquids and gas materials, and certain other hazardous solids. Foam water sprinkler or foam water spray systems protect flammable and combustible liquid hazards, including aircraft hangars and petroleum dispensing and storage facilities. These types of systems are also acceptable for use with certain Class A hazards. Water mist systems protect land facilities, including computer rooms, telecommunication equipment areas, laboratories, data centers, tunnels, underground mass transit systems, industrial machinery, electrical switchgear rooms, archives and storerooms, transformer areas, aircraft hangars, aircraft cargo spaces, museums, and historical buildings, hotels, commercial buildings, and food processing areas. All of the water-based fire protection systems go through similar acceptance testing processes to ensure the system is ready to operate and perform as designed. Periodic inspections, testing, and maintenance provides verification that the system is capable of performing as designed, and the conditions of installation have not changed in such a way that the system will not operate and perform as installed. Servicing and maintaining the system at the prescribed intervals will help reduce and avoid system impairments. Okay, gang. We've covered a lot today, so make sure you read the chapter, look over your review questions, and handle your objectives. If you have any questions, you can contact me in the office or email me at aroberts@athenstech.edu. Until next time, be safe and have a great day.